Hello, this is exercise 14C from Newton-Raphson. It's a repeat of what we did last time, but taking it a lot further because we're now looking at some of the problems you can get with Newton-Raphson method. So the problem is usually there's two general reasons why you might get a problem. One, you sometimes get asked to find a root where you can't find the tangent. I mentioned that last time. Sometimes it just finds the wrong root. A lot of what we're doing today is like that. So my first example for you is, I'll do it over here because I know there's a graph being drawn in a bit. So part 1 says, show there's an interval for this equation between 0 and 1. And the equation says that e to the 2x minus 10x equals 0. So because it's equal to 0, I'm able to just say that's my function. I'm going to chuck the 2 points, but they're saying 0 and 1. So if I put 0 in, e to the 0 effectively is 1 minus 10 noughts are 0, so that equals 1, so that's not a problem at all. F of 1 just becomes e to the 2, e to the 2 is not an obvious number, minus 10 times by 1, so minus 10. I can just do this on my calculator. Right, I get minus 2.61. Now, critically, one's positive, one's negative, so I write change of sign. And if you remember, this is what we were doing last time. We were using the change of sign method to show there's a root between 2 points. So the root does definitely belong to between 0 and 1. So you can expect that kind of question. Now, part 2 kind of goes against the obvious thing, because now I know 0 and 1, you tend to probably think to yourself, well, let's try 0.5. And if we're going to use Newton-Raphson, use 0.5. But they're saying, well, that's fair enough. But what if you use 1 instead? Why won't it work? And on all of these, we're just going to look quickly at the graph. What does the graph do? Now, you've got a graphical calculator. You can type it in. The graphical calculator, there's 1. So if I just go down to there, so the trick is to go down and then you draw a tangent at that point. So there's my tangent. And then from that point, allowing for a slightly dodgy ski-whiffy line, there's my point where it crosses, or it hits the curve. And then I draw a tangent to that, and that actually comes in really close. I reckon probably there-ish if I drew it properly. And then I do another one, and essentially you can see that that is the root I'm finding. And of course, the whole question is about finding the root between 0 and 1. So if I want to find this one, finding this one isn't any good. I don't want this one, I want this one. So the root isn't the right root, effectively. So we'll explain why it's not a good starting point when I'd write finds the wrong root. You could say it converges to the wrong root. Definitely converges, as opposed to diverges when it doesn't find any root. So 3, use the Newton-Raphson method to find the one. Oh, I see, it says starting now with 0. You can see it's closer. Being closer might not necessarily mean it'll find it, but I think in this case it will. So if I just note this formula, remember it has to have a differentiation involved. So I'm just going to do it now. I'm going to find f dash of x, and f dash of x is 2e to the 2x minus 10, and therefore, I'll go on to the next slide. So therefore, what we've got this formula that says if x1 equals 0, x2 will be, using my formula over here, 0 minus f of 0 over f dash of 0. If we just go back, remember what that was. F of 0 is e to the 2x. E to the 2, oops, that's up there, minus 10x. That was f of x. And f dash then was equal to 2e to the 2x minus 10. Now if I chuck those numbers in then, I'm going to start off with 0 equals, because I'm going to do this rather than an iterative sequence, and then answer minus fraction button, and it's e to the 2 times the answer minus 10 times the answer, and obviously wherever it says x I write answer, over 2 times e to the 2 times the answer minus 10, and that would just give me the answer, and it says an eighth. So this equals an eighth. Now of course as a decimal it's 0.125. Now, you don't have to, unless it says, you don't have to write all your answers down. I'm going to, from now on, just press equals. That's the beauty of this method. So this one equals 0.12. It said 3dp from 1296. X4, let's see what press equals. 0.1296. Alright, we're there already because it wanted 3dp, and the answer agrees to 4dp, and therefore the root equals 0.130 to 3dp. There's my graph again. Yes, 0.130. So we're happy with that. The equation, we've got a different equation now. This is our equation, and we're going to have to differentiate it at some point, so just bear that in mind. Explain why Newton-Raphson iteration fails to find a root when x1 equals minus 2. So my first thought, draw the graph. For my calculator, I've got this. So I suppose I'm just going to check something very quickly. Just check where the numbers are on the graph. Yeah, I just wanted to confirm what the scale was, and this is 1, this is 2. So on that basis, and it says why when I use x1 equals minus 2. So that's 1, or minus 1, sorry, and that's minus 2. So when you do this, you say if that's minus 2, what I would do, of course, is I'd go up here and I would find the tangent. So I don't know exactly where it goes. It goes over here somewhere, and it's hard to tell really. What were you trying to find? We're trying to find a root between minus 2. We're trying to find this root. Already it's gone a long way away from it. You can see the problem there. So if I go up there, it's going down there. This is not going to find what I want at all. So it's almost divergent, I would say. So part 1, divergent. I'm not exactly sure if there's anything else going on, but it certainly doesn't find root. Part 2 then says, well, okay, then if that's fair enough, we need to be a bit more precise. We're going to need to go in here. And I suppose if I do this, I've got a chance then to find the actual root, which is here. So very first thing I'm going to need to do is find f dash of x. And presumably I can say that this lot is f of x. So I'm going to over here write u equals the x cubed plus 4x plus 8. And therefore u dash is 3x squared plus 4. V equals x cubed plus 1. Therefore v dash is 3x squared. So f dash of x equals, what is it? V u dash. I should write this formula out. V u dash minus u v dash all over v squared. So for me here, give myself some room. F dash of x equals x cubed plus 1 times u dash minus u, the very long cubic, times v dash all over what is it, x cubed plus 1 squared. So it's a long expression, but you can see I can type that in. So if I'm going to find this, I've got to type x1 equal to minus 1.5 onto my calculator, and then it will let me find x2. And I'm just going to type that in. I'll pause this so I can type it in and then start again. Gosh, that took some time to type it in. It might not seem it because I just zipped over, but rest assured it took some while to actually type that in. So obviously I typed in answer minus this function, which is the original function with answer all over the place here, on top of another fraction underneath, which was this huge horrible fraction. And when I did it, I don't know if it's right, we'll check that in a bit, I get minus 1.299. The good thing about that is it's in the right area, so it's not 48 or something daft like this. Press equals. Alright, so it's slightly different, f for x3. And this time we're getting minus 1.35. What's it say? Give your answer to 3dp. 1352, give one more. Next one, I'm getting x4 equal minus 1.364. So that's 1.36, that's 35. Presumably this one's going to be another 0.36. Yes, it is. So x5 equals minus 1.365 now. But, if I keep going, yeah, now it stays there. So my root, according to me, is minus. Well, it's a bit, I'm getting 1.36. I need to be a bit careful here. 364.7. So it's definitely on the lower side of this. It doesn't go above the 5, even though I wrote 5 there. It was only a rounding. So I'm going to write minus 1.36. It's nearest to that. See what I said last time. 364. Did it say 3dp? Oh, that would have just made it easier if I just remembered that. So next one anyway. We've got similar situation. I've got the graph already drawn here. So use Newton-Raphson to show a starting value of minus 3 with it. All right. And so if I just start off over here, I will need to differentiate it eventually. So I might as well do it now. F of x is 4e to the 4x. And when you differentiate sine, you get cos, so this is minus cos of x. And so when I start off on this, then I'm going to say x1 equals minus 3. And I've got to do xn plus 1 equals the xn, which is going to be, for x2 this is, I'm going to have to type in minus 3 minus the function. So again, it's 4 times e to the 4 lots of minus 3. You can see what I'm doing. I'm writing this one out because it's a bit quicker to write out. Cos of minus 3. And then I'm going to divide that by f. Have I done the wrong one there? Yes, I have. So that's not, it's e to the 4x. I should have done f of x. E to that minus sine of that, because that's the f of x, and on the bottom I get 4e to the 4 lots of minus 3 minus the cos of minus 3. So I'm going to type all that in and see what I get as an answer. I've typed mine in. A quick reminder, remember this has got to be in radians, so you've got coses and stuff going on, so if you're not in radians it won't work. But when I've done this, I get a very, very familiar number. I get minus 3.1425. So that sounds like pi to me. So I'm now going to press equals x3 equals minus 3.1416. So if I press it again, I don't think it'll be far off. So yeah, that I think equals my root. Explain why it fails to find a root when x1 is minus 5. It'll be the same thing as we just saw. When minus 5 is there, dum dum dum, you can see my tangent is going off in this direction. If it goes off in that direction, it'll never come back. It'll, we're not going to find it. Diverges is the posh way of saying that, I suppose. Fail to find the correct root. So there you go. And minus 3.142. Yeah, so I agree with that. A little homework help just to finish off with. Sometimes you get asked to find a formula, and this will be useful if you look at the homework. The equation then says this. So basically I'm going to chuck it into my formula. So my formula for this, my f dash of x, if I assume the top one is f of x, becomes 4x cubed minus 6x. So my formula for the next one, xn plus 1, becomes xn, notice I'm putting the n's in and stuff because they have, minus the function. So what was the function? The function was x to the n to the 4 minus 3 xn squared plus 1, and then I divide by this 4 lots of x cubed, xn cubed, I suppose I should write, minus 6xn. Now, all we've got to do here is at the moment it's two separate parts, we've got to join them together. So I do that by putting this part over that bottom, and that, effectively I got to times it by that as well. Minus this part is already over that bottom, and then I join them together. I shall leave you to do that. It's not actually that hard, but the trick is remembering to times all of this up here, and then by 6xn, and then this doesn't, and then join the two together. Hopefully that makes sense. Any problems, email me, and we can sort this out. Thanks.